Hello everyone. In today's video, we're going to go over our process to animate the 3D models. This assumes that the model has already been separated into its independent components, and then, like this example shown here, we will be able to create these animations in Blender so that when exported, the animations will render in augmented reality and web experiences, anywhere else that you might want to use them. The first step here will be to import the new model. So the previous example showed the 1912 motorcycle from the Glenn Curtis Museum, and the model we're going to animate today is the V8 motorcycle. This model is very similar in that we're going to animate the wheels and the engine controls, as well as the startup sequence, and we're going to show a couple different types of animation in this tutorial today. The process we're going to use to animate these models is called bones. And so first we create an armature in an object mode with the add function. We add an armature, and then we're going to snap the cursor to the first wheel, and then snap the bone to that cursor. Next, we rename the bone. In this case, we're going to call this front wheel bone, because this bone is going to be used to animate the front wheel. The trick here is that instead of animating the wheels directly using keyframes in object mode, we're instead going to animate the bones in pose mode, and then use a modifier to set the movement, the orientation of the wheels to match that of the bones. Every time you create a new bone, we're going to have to follow the sequence of events. First, once the bone is set to the correct position, we need to create a new vertex group and assign it to the bone. So to do this, we have to first go into edit mode and assign every vertex in the group to this vertex group with the same exact name as the bone. This is case sensitive. And then we need to go into modifiers and add an armature modifier with that vertex group as the input. Then we go into pose mode. So this, when you click on the bone, kind of like edit mode or sculpt mode, we instead go to pose mode, and then we're going to keyframe the bone in this pose mode instead of an object mode. Here, we're trying to balance the rotational speed of the wheel with the sort of what is perceivable. So we're not looking to animate the wheel to accurate speeds. We're looking to animate the wheel so that it appears to be moving quickly, given the frame rate of the video. And so first we want it to ramp up in speed. So we set a brief break where there's no wheel motion during the startup sequence at the beginning, and then we animate one keyframe for the ramp up section where it ramps up to the maximum speed, a second keyframe for this period of max speed, and finally the last keyframe will be for the deceleration period, where we will engage the brake mechanism as well. And then again, we end with a short period of not moving to show the cooldowns. Next, we're going to add a second bone for the rear wheel. The first thing we do is snap the 3D cursor to the active element. And then the method we used here was to create a new armature and then join the two armatures together in order to add the second bone. This actually isn't the best method to do this. What you want to do is select the first armature and then go into edit mode. And only in edit mode, at least in the version of Blender that I'm using, 5.0.1, only in edit mode can you then use Shift A to add a new bone. Then, repeating the process, we're going to go into pose mode and keyframe this bone with the exact same keyframes as the front one. So we're going to check the reference, and this way the two wheels will move together. What we're doing here, and this is we probably should have done this in the beginning, is resetting the origin of the armature to the world zero. So in this case, we simply snap the 3D cursor to world zero, to world origin, and then we select the armature and set origin to 3D cursor. The next thing we're going to do here is animate the engine. In this case, the animation is a simple vibration. And so the way we're going to do this is by we're actually going to create a helper bone. And so here we have to first keyframe the position of the engine bone in order to add the noise modifier. Then we open up the graph editor, and here I split and created another window. And this in the graph editor, we go to the sidebar, and we can go add noise modifier. And then here we specifically added the noise modifier to the y axis. And so I'm not sure exactly why this is yet. I need to look into this some more. But although it shows z, the global z, it appears that these bones have a local axis of y pointing up, and so we apply the noise modifier to the y so that it vibrates up and down in our global frame. Now in the engine helper bone, we're able to apply the modifier to copy position, copy location, and we set this to copy the location of the engine bone, which we've applied the noise modifier to. And then this influence parameter is the one that we're able to keyframe. So we first set it to keyframe 0, so there's 0 influence in the very first period. Then during the ramp up period, we set the maximum to an influence of 1, and then that maintains at 1 during the high speed period, and then we again set the influence to ramp down to 0. Now we're going to repeat the same process where we create the vertex group, assign the vertex group, and give it a name to match the name of the bone exactly. And then we're going to add the armature modifier and select the bone and the vertex group that we've just created. Now you can see that the wheel and the engine will track the movement of the bone. In the noise modifier, there are two parameters that we need to set. The first is scale. 2 leads to a pretty good frequency, and so 1 is very, very fast. And as you increase the number, you get to slower oscillations. And so for the engine movement here, at this size of model, I like a scale of 2. And then the strength determines how fast the oscillation is. And so here, I like I like about 0.005 for this particular engine, although I play with this a little bit depending on which engine we're animating. Next, we're going to animate the middle drive shaft here that comes off of the engine and connects to the back wheel. Again, we first snap the 3D cursor to the object, and then we create again, in this case, we would go to the armature edit mode and then Shift A to add a new bone in this location. And right now, I'm taking note of the current rotation of this component, and I've copied these three values to a note doc on the side. And this will come in handy in a minute because in order to get the rotation to appear to be on axis, and we want the drive shaft to be rotating on its own axis locally rather than globally, which would cause it to rotate in a weird way. And so we need to take note of the rotation of the drive shaft before we apply the rotation and zero it out. Now I'm pasting these values onto the bone itself. This way the bone will match the axis of the drive shaft so that we can then just rotate the bone and the drive shaft will rotate on axis with it. And again, to note that for whatever reason, the bones have a y direction up. And so I actually had to swap the location of the y and z rotational parameters. And so this might be different on your setup, but just if it doesn't look right when you plug it in exactly, you may have to play with these where each of these three values is pasted. In my case, I just had to swap y and z. Another time I had to make one of them negative, so you might have to play with that a little bit in order to line it up. Next, we label the bone and add a vertex group with exactly the same name. And we're going to go into edit mode, assign the vertices, and then apply the armature modifier so that the object component tracks with the movement of the bone. And again, we're going to keyframe this axis to match the exact rotation of the wheels. This is because the drive gear here is a 1-to-1 ratio with the rear wheel, and so this axis will be rotating the same amount as that wheel will. It's important to double check the direction of rotation here because because of the gears, the rotation may get reversed. And so here we just we hide the bones, and you can do this on the side panel by hiding the bones. Then we can see the motion more clearly, and then we can double check that the axis is spinning in the logical direction to be driving the wheel. Now we repeat the same process for the gear itself. And now we're going to repeat this process for this small part of the drivetrain that connects to the engine. And this one, it turns out, has to rotate the opposite direction based on its local coordinate system in order to match the other pieces of the drivetrain. Now we're going to repeat this process for the first of these two gears on the front of the engine. And again for the smaller gear on the front of the engine. Then we're going to repeat this process for the brake pad. Here, the origin of the brake pad was not yet set to the hinge point, so we first need to go into edit mode, select objects concentrically around the hinge point, can select vertices, and then we select the vertices on either side so that when we snap to selection, it averages the locations so that the 3D cursor is added to the very center of the hinge point. Then we add the armature, and we repeat this process. The final step that we need to take here is to prepare an ambient occlusion map for the object. Now, this part is optional, but this is an important step for rendering the model in augmented reality. To start, we usually set the AO factor to 1 and the AO distance to 1 meter for an object about the size. You can play with these to see how it looks. And then we will bake the AO map in cycles and then apply that to the materials. And then we use a mix multiply node in order to combine the ambient occlusion map with the diffuse map. And this will vary this anywhere from about 0.2 to 0.8, sometimes the full ambient occlusion if there are pockets of the model that are heavily occluded that we want to obscure a bit more for realism. And so this you really just have to play with and see how it looks on the model in order to get the most accurate realism look that we're going for. And that's it. Once we have uh, everything animated with the bones and we apply the ambient occlusion map, we're able to then export this as a GLB file. I recommend, regardless of what file format you're planning to export in eventually, that you start with the GLB. This way we can, GLB is natively viewable in Windows, and it's very compatible with whatever viewer, and you're then able to check if all the animations worked correctly. This is important because you want to make sure that the animations are both playing but also structured correctly. When we do the export, we want to make sure that the animations are combined into a single animation, for this use case at least. So when we're exporting this for augmented reality, we want to merge everything together so that it plays as one animation, and this way it plays automatically. If you have them set up as separate actions, then the animations, then you only get one at a time, and maybe some viewers will have a selector so that you can select which animation to play, but we don't want that. We want it to simply automatically run the full animation sequence, so that's as easy for the viewer as possible. So, like I said, we export as GLB first, and then you can do things like export as a USDZ file, or whatever format that you need. So, thank you for watching. I hope this helped, and I'll see you in the next one.